What is acid and base? To explain it, there are different theories. First theory is Arrhenius theory. Next one is Bronsted Lowry conjugate acid-base theory. And the third one is Lewis theory. We are going to discuss all these theories one by one. First of all, discuss Arrhenius theory of acid and base. According to this theory, acids are the substances those dissociate in water to give H plus ions. For example, HX is a substance where X is a non-metal. When it dissolves in water, it forms aqueous solution and it gives H plus ions in aqueous solution. According to Arrhenius theory, HX is an acid because it gives H plus ion in aqueous solution. H plus is very reactive, so it cannot exist alone. It combines with water to form H3O plus ion, that is hydronium ion. So we can rewrite this equation as aqueous HX plus water gives hydronium ion in aqueous plus A negative aqueous. So let's take an example. HCl. When HCl forms aqueous solution in water, it gives H3O plus ion and Cl negative ion. Because HCl gives H plus or H3O plus ion in aqueous solution, HCl is an acid according to Arrhenius theory. Now come to the bases. Bases are the substances that dissociate in water to give OH negative ions. For example, MOH, where M is a metal. When it forms aqueous solution in water, it gives M plus ion and OH negative ions. As it gives OH negative ion in aqueous solution, MOH is a base. For example, NaOH. When NaOH is dissolved in water, it gives aqueous solution of NaOH and it gives OH negative ion in aqueous solution. That's why according to Arrhenius theory, NaOH is a base. But there are few limitations of Arrhenius theory because this theory was limited to aqueous solution only. And it couldn't explain the basic character of NH3 that doesn't contain OH negative group. For the modification of Arrhenius theory, another theory given by Bronsted and Lowry. According to Bronsted Lowry theory, acids are H plus donor and bases are H plus acceptor. For example, HCl. When HCl dissociate, it gives H plus ions and Cl negative ion. Here HCl donates H plus. As it donates H plus, according to Bronsted Lowry theory, HCl is an acid. When you study the same reaction in backward direction, you will see Cl negative accepts H plus ion. As Cl negative is H plus acceptor, it is base according to Bronsted Lowry theory. Now come to the another example, water. When it dissociates, it gives H plus ion and OH negative ion. As water donates H plus ion, so water will become acid as per the Bronsted Lowry acid-base theory. And here OH negative, it accepts H plus ion. That's why it will become base. So we have observed here acid and base always exist in a pair. Every component has a conjugate. In this example, water is an acid and OH negative is a base formed by H2O. So OH negative is a conjugate base of water acid. Let's study another example. Here H2SO4, when it dissociates, it gives H plus ion and HSO4 negative ion. As H2SO4 donates H plus, H2SO4 will be an acid and HSO4 negative, as it accepts H plus, it will become conjugate base of H2SO4. Now examine another example. When HSO4 negative, it dissociates and gives H plus ion and SO4 2 negative ion. As HSO4 negative donate H plus, it will be an acid. And SO4 2 negative, as it accepts H plus, it will be a conjugate base of HSO4 negative. So we have learned according to Bronsted Lowry theory, acid gives H plus and conjugate base, and base accepts H plus and gives acid. So for example, if I ask you what is the conjugate base of HSO4 negative? So here HSO4 negative acts as an acid. So when it dissociates, it donates H plus ion and form SO4 2 negative. This SO4 2 negative will accept H plus and become conjugate base of HSO4 negative. So your answer will be SO4 2 negative is the conjugate base of HSO4 negative. Now come to the another question. What is the conjugate acid of HSO4 negative? Here HSO4 negative acts as a base. So it will accept H plus ion, and after accepting H plus ion, it will form H2SO4. So H2SO4 will be the conjugate acid of HSO4 negative. According to Bronsted Lowry acid-base theory, each component has a conjugate that we just have learned. Weak component has a strong conjugate. For example, when water dissociates, it gives H plus ion and OH negative ion. Because water donates H plus, so it will act as an acid, and OH negative will be the conjugate base of water. Here we know water is a weak acid, so its conjugate will be a strong base. Similarly, a strong component has a weak conjugate. For example, H2SO4, when it dissociates, it gives H plus ion and HSO4 negative ion. As H2SO4 donates H plus, it will act as an acid, and HSO4 negative, as it accepts H plus, it will be conjugate base of H2SO4. So as H2SO4 is a strong acid, its conjugate will be weak conjugate base. Bronsted Lowry theory also has a few limitations. This theory was limited to species those accept or donate H plus ion. It doesn't explain the acidic character of BF3 like species that doesn't contain H plus ion. To the modification of this theory, another theory given by Lewis. According to Lewis theory, lone pair donors are base and lone pair acceptors are acid. For example, NH3 and BF3. NH3 contains a lone pair of electrons, and BF3 is electron deficient species. As the octet of boron is incomplete here, it has only 6 electrons instead of 8 electrons. So BF3 is electron deficient, and in ammonia nitrogen has a pair of electrons. So here nitrogen from ammonia donate lone pair to BF3 via covalent coordinate bond. As ammonia donate lone pair to BF3, ammonia act as a base, while BF3 accept lone pair from ammonia, so it will act as an acid. So let's summarize all these theory. First theory was Arrhenius theory, second is Bronsted Lowry acid-base theory, and third theory was Lewis theory. According to Arrhenius theory, acid gives H plus ion in solution and base gives OH negative ion in solution. According to Bronsted Lowry theory, acids are H plus donor, while bases are H plus acceptor. According to Lewis theory, acids are lone pair acceptor, while bases are lone pair donor.